As I mentioned at the town hall, and as Rick has posted on his blog, 4 of our students have developed a tongue-controlled wireless device for use by people with quadriplegia. Correct me if I've got that a little bit wrong. All of these students are connected media at Cornell Tech, and as most of you know, Connected Media is a 2-year program launched in 2014 that's offered by the Jacobs Institute, which is our academic partnership between Cornell and the Technion. We know that Roosevelt Islanders have a great respect for this island's long-time commitment to people with disabilities, and community activists who were involved with Cornell Tech early on, most of whom are in this room actually, they were very thoughtful in ensuring that a number of our commitments center on seniors and the disabled. Whenever I talk to our students and our faculty and our staff and actually the wider Cornell University community, I speak very much with pride about Roosevelt Islanders being a very inclusive community who take care of each other. I think there's something like 35 or 40 organizations on this island, and everyone has embraced those with physical, emotional, and mental challenges, and they want to do everything they can to see that the needs of this population are addressed. And so one of our commitments actually reads as follows: create an environment in which Cornell Tech students can research ways that technology can enhance the lives of older adults and the disabled. And so that is what we are trying to do. And we have students here tonight who have jumped right in, actually, and they will tell you about how they are helping us to meet this commitment. The students who will present to you tonight are Oliver Hoffman. He has a BS in computer science, and he has experience interning in different software startups. He's interested in technology that can bring people together or improve other people's lives. His goals for the future are working at a software company where he can be creative and hopefully make Pallette a reality in the future. Dan Levine, next to him, lives on Roosevelt Island. He is a Roosevelt Islander, one of our students who lives on Roosevelt Island. We're very proud of that. Also, of course, a Connected Media student. He received a double BS in mechanical engineering and computer science from Cornell University. He has experience working on assistive walking devices and nature-influenced methods of robotic locomotion. He enjoys design and adventure, and he wants to contribute ideas and technologies that will have meaningful impact. Sean Ramson holds a Bachelor's of Software Engineering from McGill University. His past work involves STEM education, productivity, and news delivery. His interests lie in novel interaction between the digital and physical world, privacy, preserving technologies, and humanitarian technologies. And Rohit, am I pronouncing your last name? Den? Sorry. Received a BE in computer engineering from Delhi University, India, and worked as a software engineer at Adobe. He wants to use his technology skills to build something useful for people and have a meaningful impact on their lives. So they're here tonight to present about the Pallette project, and they are really looking, they're students, so they're looking for your feedback, not only on Pallette itself, but maybe on this presentation as well, because they're out there learning and presenting and getting feedback, and that's hopefully we can both benefit and learn from each other tonight. So I will let you take it away. Thank you.
So thank you so much for having us here. This is actually the first time that the 4 of us as a team present Pallette to the public. We've done so individually or as a couple, but never as a full team. So this is really exciting for us. It's the first time for us. So Pallette started a year ago during a human and computer interaction class, and ever since it's been improving, and we want to show you guys our journey so far, so let's get started. So what exactly are we trying to do? Who are we trying to help? And what are we trying to achieve? Our goal is to help people with quadriplegia achieve greater independence, mobility independence. As of now, as you know, people with quadriplegia, the best way to showcase this example is with Raul. He's a person with quadriplegia, which means that he's paralyzed from the neck down. That means he cannot move his arms, legs, or anything else, and therefore he has to live his everyday with the help of a caregiver who helps him go about his day. All the tasks he does in one way or another require some sort of help. Now, the thing is that nowadays, these people are always dependent on someone else to perform their daily tasks. And that is exactly the problem that we want to help solve. So as of now, as Dan will explain, there are many different technologies to help them achieve this, but in one way or another, they're not perfect. And we believe that there's room for improvement. So Dan, if you can explain that.
All right. So like Oliver was saying, there's a lot of technology out there right now. If you look at a few different ones that exist, you have the chin joystick. The chin joystick, you can imagine, sits at your chin, and you move your head to move your wheelchair, for example. But one of the big disadvantages is it does require this external piece, and from our discussions, we found that when people are riding down the street, they hit like a bump in the sidewalk, then the chin joystick falls out. So that was one issue with that particular piece. The next one is the mouth joystick. The mouth joystick is much like the chin joystick, except instead of sitting on the chin, it's held by the mouth. But again, you have this large external arm that has to fit out. The sip and puff is a pretty famous one. It's very much like the mouth joystick, except that you can sip and puff to have interaction with different technology. But again, it's got another arm and it's external. Now, one technology that's sort of emerging that tends to work pretty well is voice commands. However, voice commands, one issue that we found when we were talking with people was that it sort of disrupts your privacy. So if you want to move forward, or you want to write an email, or you want to use your phone, or you want to do whatever, you have to say all of this. So you can't just think it and type. You have to sort of give up your privacy a little bit. So what we want to do is make an individual control private and discrete. And in more layman terms, that means we want to create a device or a means of control that doesn't have external dongles and that doesn't require public speech. And how can you do this, and where would you put that? That's very much how it came to a tongue control device. It's inside the mouth, it's discrete, no one has to see you really using it, and you don't have to say anything. So Sean's going to give a little bit more about sort of the concept and some of our first prototypes.
So we started out with this idea of using the tongue. That was our building block. And so this was our grandiose vision. This is one of the many prototypes that we went through, but the idea being to use something very similar to a retainer that would fit within the palate of the mouth, hence the name. It would be wireless, meaning nobody would see anything coming out of your mouth. It would fit snugly within the teeth, comfortably, and it would be controlled primarily by the tongue, using it similarly to a joystick or any other form, but again, discreetly within the mouth. So this is all well and good, and it's a great idea, but I think it requires a bigger vision. And our bigger vision is that right now, yes, this piece of technology can do something like control a computer or control a phone. But let's think about what a computer or a phone can control. Today, it can do a few things. You can do your banking, you can check your emails, update your Facebook status. Sure, all that's well and good. We have this thing called Internet of Things, IoT, that is really starting to emerge. And it's an all-encompassing term that basically means having every single item in your house connected to the internet. And while that sounds like a scary thing, it actually is very cool and empowering for our vision. Because now imagine if I, with the use of something like Pallette, could turn on my lights. What if I could set the temperature or turn on the television all from the comfort of the wheelchair, without having to do any form of getting up or asking or demanding some external party. That's what our vision is. Our vision is to create something very simple, very intuitive, that will allow us to control the world around us. So with this IoT, we can achieve that. And this type of technology is being incorporated more and more throughout all the technology companies, and even housing and all of that infrastructure is being built out now. So this is our first of many prototypes, and we did something we did something kind of bold. We took a IBM laptop, and I'm sure all of you are very familiar with the iconic red nub that exists on the old IBM laptops, and we destroyed it. We took it apart and we retrofitted it and shrunk it down to fit into a sports retainer with 2 simple buttons and the control with the red nub. And that had, at the time, this was merely as a proof of concept, this attached to a wire which fed out the side of the mouth and allowed anyone to really use a computer as they would with a normal trackpad and mouse. Do we want to demonstrate the video?
Show it at the end.
Yeah, okay, so we have a little video of that last prototype working. Because there's no wireless here, we can't do the YouTube video, but we'll show it to you again.
So this was our next prototype, and this was the next big step for us was to make it wireless. The wire coming out of the mouth. We now validated our model. We figured out that this was definitely something that people wanted, people needed, and so our next step was to make it wireless. We had 2 buttons, and we found that the nub was not a good control system, and instead we moved towards something more akin to like a Game Boy joystick, a PlayStation joystick. And so that was our next step, and I believe Rohit will take you through the next part.
Okay, so I guess it's the last little note on that last prototype. So one thing you notice here is this does look kind of big, and it's true, it was pretty big. So we managed to make it wireless, but the form we still hadn't got quite right, and then the mode of interaction, while it was improving, still was a little bit funky. So that sort of leads us to where we are now and where we're going. So this looks like a bunch of wires, and it is a bunch of wires. The core part here is this little sensor. So doing sort of research down this line, we found that a lot of the moving parts are sort of adding bulk that were really hard to deal with, especially inside the mouth. And we found a method to do this, sort of looked through research and found a method that involved motion tracking using proximity sensors. And proximity sensors they're everywhere, and they can be made really tiny. So that is a proximity sensor, and this was us getting that proximity sensor to work. So our new design is going to be an array of these proximity sensors embedded in plastic. So the whole thing is waterproof and doesn't have any exposed sort of funny components. And you'd be able to move your tongue around and sort of press the top of this thin retainer for motion. And the whole package right now is looking very small, so we're very excited about that. That's where we are presently.
If I may add something, as you can see, this is still incredibly big, or to an extent it's very big. Fitting that into your mouth would be annoying, it would not let you speak, so it still brings about like a lot of problems, more than what it's solving. Therefore, so that's what the main challenge right now is, actually trying to make it as small as possible, and it is actually something that we can do. These proximity sensors are incredibly small, and just by fitting it into a very slim and thin, not even retainer, like we're trying to find a way to just kind of stick it to the upper part of your mouth, so that it lets you speak while you have it inside. So that is actually the main challenge right now.
And then just to append one more thing to what my colleague just said, the other thing that really is important to drive home is that right now these technologies are on the orders of thousands of dollars. And what we're proposing here, we can build for on the order of something like $50 to $100.
So
we're working.